Hi, in this demo we're going to do a little bit more with our actions. We already have a rotating yellow square. What we want to do is add a little red square that is a child node of the yellow square and rotate that along with it. If we add a child node to the yellow square, the red square will rotate in the same way as the yellow square. So if the red square is located up here in the corner, it will rotate at the same rate as the yellow square, but that's not what we want to do. We want to give it the appearance of rotating, of not rotating, while the yellow square rotates. So when the yellow square is here at 45 degrees, we want the red square still to be non-rotated. And then as the yellow square rotates, the red square will continue not to rotate all the way around. So how do we do this? Well, we have to apply a rotation that is equal in size, but in the negative direction to offset the yellow square's rotation. Because remember, nodes inherit their parent node's properties. So if an action is on a parent node to rotate it, a child node will also rotate. So we want the appearance of the red square to be stationary. So this little graphic just shows us what we want to do. So let's go ahead and do that. In our simple square with size, we're setting up two squares. We make the outer square from the parameters that we pass in to simple square with size, and we make the inner square with a red color. We wanted the inner square to be right. We get a square size by dividing the width and the height of the size that we pass in by 4. So we're just scaling down to 1/4 of the size of the first square. And then it's red, and we pass that square 2 size in. Now, we need to position square 2 within square 1. As soon as we add it, the position for square 2 is going to be an offset from the position of square 1. So we're offsetting by 10 in the x direction and 10 in the y direction. Positions for nodes are like positions for core animation objects. They're at the center by default. So we make a point, CG point make 10, 10, and then we position the red square 10 points in the x direction, 10 points in the y direction away from the position of the yellow square. Finally, we add square 2 as a child to square 1. We set up two actions this time, a clockwise spin and a counterclockwise spin. The clockwise spin is a rotate by angle -2 times pi over a duration of 3, and the counterclockwise spin is a rotate by angle 2 times pi over a duration of 3. So now, when we apply these actions to square 1 and square 2, square 1 is going to rotate clockwise. Square 2 needs to rotate counterclockwise to counteract the clockwise rotation of square 1 to which it's attached. And then finally, we return our square 1 node. So let's see if we've done everything right. Again, what should happen is that the yellow square should rotate clockwise. The red square should appear not to be rotating at all. So here we go. Let's see if that worked. And there we go. So the yellow square is rotating clockwise. The red square is actually rotating counterclockwise, but in the context of the yellow square's rotation. So that nullifies the rotation that's already on the red square. And we can see this. Let's just comment out squares 2's action, which will rotate both squares. Let's go ahead and do that. So it's easier to see that square 1 is rotating. When we do the square 2 action, we're actually counteracting the rotation of the yellow square. So let's put that back in before we go to the next step. So that's cute and it's interesting, but we're still not really doing much. Well, we know that nodes are responders. So we could set up a touch event on a node, and on any node. The SKScene itself is a type of node. In fact, SKScene inherits directly from node. So we can set up a touch event on the SKScene's view to move our yellow square as it's rotating and as the red square is counter-rotating. So let's see how we would do that. Here I've overridden touches ended with event. I make sure that I have a touch count of 1, and I get, if I do have a touch count of 1, I get a touch, which is any object from the touches. Since there's only one, it's going to be the object from the touches. The next thing I want to do is get the XY coordinate of the touch. I'm going to move the yellow node to the XY coordinate of the touch, but we have to be careful. If we don't invert Y, then it's going to move in the opposite direction that we intuitively think it would with respect to Y. So we need to invert Y, and the way we do that is when we make our touch point, we get touch location and view self.view.x. Don't alter that, but then we need to subtract the location and view self.view.y from the bounds size height of the view. Self.view is the SK view that the scene is located in. So now we set up an action, again, to move to that touch point over a duration of 2 seconds. So this is simply move to touch, and it is move to touch location over duration of 2. And then we find the outer square node. The outer square node we have named square. Now, child node with name is an excellent way to find a named node. Now, where do we apply this name? Well, we did it when we set up the square. And I actually modified it right here, and I said square.name is equal to the NS string square. So now we can find that node anytime we want it. So we get the child node with name square, and then run the action move to touch on that child node. And this is how it works. So now if I touch, the square will move and continue its rotation. The red square continues its counter rotation, and everything works. So this is the power of SpriteKit. I am able to set up a node tree, have these nodes have independent actions, and then perform another action on a node while the other actions are continuing to execute. And so I can very rapidly and simply build up trees of these nodes for something like a game. Thank you very much.